this next talk in the performance track, although as you can see from the title, it could well be fitted into the embedded track that's also going on. So we're going to be looking specifically at analyzing and solving Qt UI performance problems on embedded hardware. So this will follow on a little from what Milian said in the previous talk, and if you weren't in for that, I would encourage you to watch the video of it, which will be online, I'm sure, after this event. He looked at the specifics of application code and some of the tools that I will reference, but he looked at them in a little more detail, so do check that out. So as a means of an agenda, we will first of all just have a brief introduction to myself and Mentor Graphics, and then I have a section that's entitled Performance Matters, and then briefly, just to set the context, we'll talk about typical performance problems, and then get into methods, tools for solving performance problems. And then for about the last 20 minutes, I would like to run some examples of using trace analysis, which we'll identify in the previous section as potentially the most powerful performance problem solving software that's out there, or means. And then we can we'll have a conclusion and questions. Let me set my timer going. So as an introduction, you've seen I'm Phil Brumby. I'm a technical marketing engineer, formerly a software engineer in the user interface technology, and also in the mobile gaming space a long time ago in Scotland before that. And for the last 5 years, I've been specializing in graphics and UI at Mentor Embedded. And that's involved working closely, really, with our embedded customers and their needs once we've enabled them with software, tooling, and whether it has been training them or going on site and working in services for their graphics and UI needs. And that's been across OSs. So that includes Mentor's own RTOS, which is called Nucleus, but also Mentor embedded, but also embedded Linux and Android to a point. So what that background gives me really is a focused and valued approach on this topic, in that I come at it from the end user's perspective, who at the end of the day is the most important person in all of this. If you're producing something, if your end users are dissatisfied with the performance of the application, and that manifests itself through the UI, then you're going to have issues with the uptake of your product. So just briefly, Mentor Embedded is a single division within Mentor Graphics, and spread globally. And it has Mentor has a committed history to the Linux OSS initiative, if you can see from some of the statistics, and over 20,000 users of our embedded tools. So Mentor Embedded and Qt, you might not be aware of Mentor Embedded in the Qt space, but Mentor has a long history in the embedded space, so 20 plus years of working in the embedded market, enabling customers across verticals, automotive, industrial, medical, and consumer electronics. And this is via commercially supported and customizable Linux, but also for real-time control systems, developers can take advantage of Nucleus, which is Mentor's own RTOS. So this year, Mentor has been working to enable the use of Qt with its own portfolio of embedded software and tools. So specifically a Qt integration with our own RTOS Nucleus, and that covers Qt Core and GUI for QWidget-based solutions for the time being, but also use of Qt with our Geneva-compliant Linux automotive technology platform. So let's talk about performance matters. So first of all, why does UI performance matter to Mentor Embedded? So just a quote from a CEO that I dug up, but no matter how good your underlying system is, the user will only remember your user interface. If you fail there, you will fail, period. And that can be applied to obviously the design and the usability, but also the performance of your UI and how well they interact with it. So for Mentor, after enabling the customer with a UI technology, the operating system, middleware, and development tools, we have a vested interest in ensuring a quality product is produced, because it's been mentioned in the keynotes today. Qt is on the top, and that's what you see. But in a lot of systems, we are everything else underneath and the software tools for doing it. So we have a vested interest in making sure the end product performance is good. So why are performance issues problems an issue today? Again, this isn't new, but it was referenced in all three of the keynotes this morning. So expectations from the smartphone experience has raised consumer expectations, significantly raising the performance bar for all embedded devices. So this is the iPhone effect. And despite advancements in hardware capability, embedded UI development must still pay careful attention to platform capabilities. So this is a subject that we could have an entire talk on in itself, but you must, at the start of a project, ensure you have an understanding of what your hardware is capable of. If you're going to be driving a 720p screen, you need something with a bit more grunt than a 400 megahertz ARM processor. So careful attention to your hardware at the start of a project will go a long way to dealing with performance issues. But that isn't our topic for today. So I talked about my approach being from the customer's perspective. So we can have a look at some typical performance problems. Excuse me. And I've summarized those into three categories, really. So first of all, responsiveness. So how quickly a UI responds to an input, whether it's a key-based event or increasingly now in the embedded space, a touch event. And what you're looking to avoid, obviously, is UIs that are perceived as laggy or unresponsive. And then another key category, so these are summarizing a lot of things, but I've entitled it animation smoothness. So typically measured in frames per second, and here the animation smoothness is going to have a significant influence on the user experience. And so as typical values, obviously you are looking at maintaining something between 30 and 60 frames per second to avoid the customer or end user of your product perceiving performance difficulties. And then finally, startup time. So every engagement we have with Mentor Embedded based around the OS, this conversation comes up very early. So there's a perceived interest around the startup time, and this is a performance problem if your application has a delay as it starts up. And this is something that obviously could be affected by the OS, but also the UI framework and the application processing, the associated resource loading, and graphics computation. So that's the view we will take of performance problems and try and solve later on. Just as means of an example, I want to run a video here of what you would deem a bad user interaction experience. So this is just a sample in-vehicle infotainment UI built with Qt Quick or QML, and this is running on our own ATP automotive technology platform under Linux, and it's taken from an IMX6 Freescale board. So what we're going to see here, just at the start, the user is navigating around the UI. Obviously this is just a demonstration UI. You wouldn't have a red one in a real car, but within the music and multimedia tab here, we've got albums. But when the user comes to scroll these albums, we perceive a lag in the interaction, and certainly a frame rate drop as he tries to whip through his albums here. So I use this as an example of a typical performance problem that an end user might be concerned about, and will bring down the experience of the use of an embedded application. And in this example, we'll look at it later on to solve what was the underlying problem. Oops. So before getting into means of analysis, it's worth just talking about performance metrics. So remember, we're talking about the whole system here. We're not talking about the user or the Qt space. So to get to the bottom of performance issues, we must understand system metrics for measuring performance. And then we can use them to tell the story of what is happening on the hardware at any given time. So we're talking about looking at the execution profile, whether that is the looking at your tasks, which ones are running, which ones are accessing the processor, the events that are getting thrown around, and then specifically looking at the CPU, the state of your CPU, utilization, who is using it, if you're in a multi-core access system, if there is any blocking going on, and then memory as well, understanding your memory pools, getting a visualization of them, where the allocations are taking place, how they're being used, and any file system activity that you might have going on. So all of this is underneath the system, beyond the UI space that, as a developer, you might have most experience in. And then I've added just a final point that these system metrics should be coupled in effective performance analysis with what I've called computational user-defined metrics. So by that I mean frame rate. So this is a value that needs to be generated at runtime to indicate how many frames you're drawing at per second. But then it can be customizable to how you perceive something to help understand performance, whether it's runtime data requests, what sort of pixel load you have, how much of the screen, what percentage of the screen you're redrawing at any given time, as well as what is happening when the system starts up. So these are computational user-defined metrics. So one final slide before going into the means of analysis. I've just called this a QWidget or QML solution. So we are talking about the embedded space, remember, and it is our experience from engagements that there's still significant user cases existing for the deployment of both Qt solutions. So we still see the need to deploy QWidget-based UIs where we have memory considerations, the ability to have a smaller footprint, but most critically, if hardware has no GPU, your Qt Quick or QML solution would have to be software rendered. Not all the processors that are on boards without a GPU can manage that. But also that some markets still require static and traditional 2D button and control style UIs. So I'm talking specifically about medical here. This is where we're engaging with Qt. The great strength of Qt Quick is dynamic animation, effects, use of shaders. In a medical device, there's less of a need for that. So QWidget-based solutions are still something we consider, and in my second analysis example, we'll look at a QWidget-based one. So ultimately, the best performance analysis tools should cover both. So methods and tools to analyze performance. If you're not familiar with this title, I'd suggest you're in the wrong place, and maybe a corporate marketing meeting somewhere in Berlin that you could attend. But we'll start with the printf, and again, as a means, as a starting point, we're assuming debugging didn't help. So a common starting place can be that I'll add some printfs, and we have an example usage there, whether it's direct printf usage or cout in C++. Something that is very familiar to anyone who's a developer. And the big strength is it's simple and it's easy and it works almost everywhere. Significant cons against it are the idea that it is low performance. So we're talking about the string formatting that is associated with it, and then any I/O considerations if you're outputting over serial. Remember, you're analyzing performance here, so you want to have the least intrusive means of analysis possible. As a developer, there's a certain cycle, I guess, in using printf, the add, rebuild, rerun, tweak idea that you need to seed your code widespread with it, and not knowing where to start means that you're going to run through this cycle. And then, of course, there's post-processing the results. So there are tools obviously out there, whether it is Perl or Awk, but nobody likes to use Awk. Well, if you do, you're in a minority. But the means are there to analyze and your printf data if you've put it out, but we would like to find better means for doing that. So the idea is, yes, it is the right tool in some cases for displaying output, but is the wrong tool for this job, specifically performance-wide, system-wide performance analysis. So we go then into statistical profiling. So again, if you attended the previous talk, and if you didn't, you should certainly go and check it about apps on speed. But statistical profiling was talked in depth, specifically the perf tool, but the idea of statistical profiling, obviously, is to determine which code is typically the greatest user of the CPU or cache. Then we have a sample, just a simple sample perf usage there. And as it was indicated before, the real strengths of statistical profiling are high performance. It's very minimally intrusive, and it is great for the means of hotspot locating. So that is understanding which functions are using the CPU the most. Slight cons against it. So obviously, I'm not discounting it here. It has its place and its use, but it is focused on the utilization of hardware resources, and it is ultimately a static table aggregating all of the results of your, which functions used the CPU. You can't narrow in on problems. There is no timeline, or again, referencing the previous presentation, there was a desire for a perf with a nice front end, a nice UI that might enable that, but you can't move up and down a timeline to really understand where your performance problems were. And it only, finally, it only really helps visualize repeated pattern problems. So let's say you've got a one-off glitch in frame rate that happens sporadically, maybe once, twice, every 2 or 3 minutes. Statistical profiling isn't really going to help you in that scenario. So, right tool for throughput problems, but wrong tool for other jobs, like that example of one-off glitches in frame rate or responsiveness. So we move on to the topic of tracing then, and this is a topic that's going to carry us all the way through. We're going to build on it into our demonstrations. So tracing, like printf, but lower level, so significantly higher performance. And tracing gives you the ability to correlate activity at many layers, because first of all, you can seed your code significantly more than you would with a printf because of it being higher performance. And so similarly, it then reduces that cycle we saw of rebuilding and tweaking and rebuilding and tweaking. You can be a lot more liberal in your use of trace points. The big con against tracing, just as a single means of analysis, is the idea of post-processing the results. So that will lead us naturally into the next slide, but if you thought you had a lot of output coming out from your printfs, if you study your tracing data, it'll make your mind spin unless you have the means to post-process the results. So to summarize that point, the idea is that we have a haystack of data now, but where is the needle that is going to that is the root of our performance problems? So you need the means to view your trace data. So here we have trace viewing, and this gives us the ability to show the events that we have output graphically. And trace viewing often comes with the ability to search and filter your data to a certain level under fixed performance metrics. But it still depends on the user really to traverse through a lot of data to find the issues that are being displayed in that. And trace viewing often comes with fixed or limited data sets. By that I mean limited metrics for viewing. So yes, you may get CPU use, memory use, but there's no means to add in custom application level viewing. Remember, we want to get a view across the entire system. So you need a more flexible means of analysis to calculate and display to the user higher levels of patterns of data. So yeah, so before going into the means of analysis, it is worth at this point talking about QML Profiler. So QML Profiler, if you're not familiar with it, comes as part of the Qt Creator IDE, and it is a purpose-optimized performance tool for Qt Quick or QML-based designs. And it is a great tool for QML and should be used within your toolkit of analysis, but it is limited to the UI space in which you are developing, so no system-wide interactions and specifically no QWidget coverage. Now, since I have been here, I've been wandering around the displays. I came across Gamma Ray upstairs. You should take a look if you haven't already, but this is a means of performance analysis for Qt widget-based design. So there is a tool out there specifically for the Qt widget space. I wasn't able to update the slides in time to add that in. So QML Profiler, I'm going to use it if I think my problem is strictly within my application, but it should be part of your toolset. So moving on from, so we had trace, then we had trace viewing, and now trace analysis. So the idea here is to have a task-centric analysis to calculate and display system-wide and including the application, a more user-defined visual analysis of the system. And that's where I would like to switch into a demo of the means of doing that within a tool. So I'll just run this slide again. So this is a bad user interaction experience. Start the video. So we have just standard interactions here with the in-vehicle infotainment system, but the perceived performance problem occurs when the user goes into his multimedia section and starts to scroll his albums. So we perceive a lag as he interacts and significant jerking and frame rate issues. So at this point, I would like to switch into some trace analysis software. So we're going to look at a session here. I've already recorded my trace data from the application running, and now we're going to try and build up a holistic view of what the system is doing and see if we can narrow in on the performance problems. So the tool you're looking at is Sorcery Analyzer. And we will use specifically to get to the bottom of what is happening what are called analyzer agents. So you can see in this list down the side we have CPU use, file access, what is happening with our kernel events, memory. But specifically, we have extended this analyzer software along with the Qt work that we've been doing to add in some analyzer agents specific to Qt, and that's where we need to start really to start investigating the system. And the first one I'll open is this Qt UI smoothness. And so this will highlight times when animations become jerky or frame rates decrease. So we have a means of configuration at the beginning. I'm going to say bad frame rate when we drop under 30 FPS, and I'm going to average the frames. I'm just going to take a single value for a timing event for every single frame that we see. So we have a nice spiky graph first of all, but let's have a look at this state graph across the top. So this is indicating UI smoothness, and so it's going to be green when the analysis agent is telling us the frame rate was okay and averaged over 30, and red when it dropped below 30. And then we have a line graph of average frame rate. Let's zoom in on this section specifically. So yes, we are confirming we've got frame rate issues here, and you can see that as the user was interacting with the system, the frame rate was dropping off. So we need to start building. Up more information. So we have a Qt UI latency analysis agent, so an agent to determine where the Qt system has latency issues. Go and find, there we go. So here specifically, we can see a line across the top. This is called input event processing. So this is the time taken from when an event was added into the graphics in the graphics scene, and how long it took to be processed. So here we've got a significant delay, over 100 milliseconds on this specific event. We don't have the event detail at that point. And then across the bottom, we've just got our frames and any associated paint latency. And you see a couple of slow frames, but what it actually shows is during these points, we weren't getting any frames at all. So we can have a look at the Qt core events that are going on. So we've got our core events, and we've got the scene events. And specifically, I'll zoom in here. You can see within the scene events, this is the mouse move was the last event processed, and we've got a great big long drag between that. So it's just confirming that this is the point that the user was interacting. So we've confirmed our issue. We need to get into it a bit more. So at this point, you might go and check out what is happening in your Qt application. So we can have a look at our QML files, and you can see specifically here with binding going on. So that is the reassigning or dependency of data values within this music album menu.qml. So I would use QML Profiler at this point and jump across into it. So we have our timeline across the bottom here for our QML Profiler. You can see the compiling at the start. But if we jump into it, you can see we have creation going on within our music album menu QML, and the specific binding is associated with this model index property. So I jump into the class header. Just have a look at the property declaration. So for model index, we are calling this set model index function, which I'll jump to, and then that itself is calling fetch music info, which is just this function here. So we get a pretty clear picture straight away that there is a database connection going on here. So we're querying a database for our menu information, and that is looking like that's going to be at the root of the problem. So I've added, just to take this a step further, I've added in trace points within this function. And then going back to our analysis tool, I'll just kill a couple of these. we are going to use the ability to create what you could call a custom analyzer agent. And within this, I'm just going to pick out the tag that I had in my trace API calls there, and the event name. And of the types of graph that I can make, I'll just use a state graph because it's string data. And then we have an insight as to what is going on in that function within our QML file. So 50% of the time connecting to the database, obviously is a canned example, but then running a query and then fetching data values there at the end. So to take it a step further, to conclude, I added trace data into our third-party database software. And again, we're going to have a look at the state graph. And then you get a visualization, really, of just what is happening then within your third-party database software as well. So you can see, if you're familiar with databases, we've got initialization, creating the session, running the query. But the point is here that you have managed to, in the use of these analysis agents, build up a holistic view of what is happening within the system. We've made use of QML Profiler, we've taken frame rate as our starting point, and it has led us all the way down here into the database software. So obviously what is happening here with the connection as a means to fix the issue is that it's a lengthy process that is happening on the UI thread. Maybe your database software is constrained by network speed or hardware, or your third-party software isn't particularly optimized, so you could look at optimizing that. But the most sensible thing to do would be obviously to offload the overhead of this database lookup to another thread, and so make it asynchronous with the UI thread. I guess there's also the option of using placeholder data, which will be used within the albums that you can see and only updated to the final values once that is available. Okay, we'll press on. So a second use case, I've called this intermittent frame rate issues. So this demo itself is just a mocked-up sample smart energy washing machine UI built with Qt widgets, and this is running on Nucleus, which is our RTOS, and I recorded this out of QEMU, which is a emulation environment. So what you are looking for here is this idea of intermittent frame rate issues. Now it's most visible when we have a progress bar going on. I don't know if you caught the first one there, but I run round again. You are just looking for sporadic sticking points, and so we're going to schedule a wash here for another time. But have a look at the progress bar and the counter. We've got sticking points, and which are perceived as performance issues. Really, they are performance issues, and there's no repeatable pattern to it. There's sporadic time between these sticking points. So again, we'll go into our trace analysis software, and I've pre-populated this one for time slightly. Oops. Just reset. There we go. So our starting point again is our Qt UI smoothness. Remember, this is a Qt widget based solution now, and you can see that we have significant frame rate drop-off at points. These aren't specific in their timings. So we could, as a means to understand what's going on, I've launched CPU use. So this is a lower end piece of hardware. So CPU use is pretty chocker already. It doesn't really give us anything. You can see that the CPU is busy a lot of the time. We might load up our Qt UI core events to try and establish what's going on. Well, all we really do here is confirm that the last core event here that was processed was a paint, and then there was a huge delay. So, and you can see in the bottom track here we're not getting any frames. So we know this is the sticking point now. And then in this next graph, we will look at this state graph. This is called the nucleus tasks profile. So this is giving you a visualization of just what is happening with our underlying tasks. So here we have our root task. So this is the main UI thread. And you can see that, let's zoom in on this massive drop off. You can see that it's pretty busy. But at this given point here, it is ready, and so the ready state means that it is wanting access to the CPU, but for this lengthy period here, we don't get it. So the UI thread specifically here is being starved, and you can see just further up the list, the culprit here is this task that is running and hogging access to the CPU. So if we just zoom out and maybe try and confirm, I can add a cursor here just to look at the other drop-offs. Zoom in again, you can see we've got a task, this task that is hogging access to the CPU. So as a means to maybe, again, this is a slightly canned illustration, but as a means to understand just what that task is and what it's doing, anybody guess by the initials of what it says? Garbage collection. So a sporadic task that is cleaning up, and just to confirm that, we could have a look at the memory profile. So we've got system memory here, but then also our individual pools. And here, yep, you can see we're reclaiming memory. So it is a garbage collection thread that is going on, and specifically, obviously, we can't kill that thread. But the issue here, and this is a canned example, but it did happen with one of our customers, is the garbage collection just had too high a priority. You know, and it can be as simple as that, okay? But getting into the system and ultimately finding it could be a lengthy process. So this idea of a holistic view of the entire system, from frame rates down to your tasks, CPU access, and dynamic memory profile. So we'll move to our conclusions. So there are a lot of tools out there. The previous presentation is a testament to that. But the idea here is I've had to take a more holistic view, because we're talking about the entire system, is that using the right one for each job makes all the difference. So every one maybe has its place, but the best approach really that we identified was tracing, and it gives you the best coverage for system-wide performance problems. but the perceived difficulty there is the need for a tool to process and help visualize it all. So what you were looking at there was Sorcery Analyzer, which is a Mentor product. The Sorcery Analyzer tool can perform trace analysis at the OS layer, at the Qt layer, and even in the application layer, as you saw when we jumped into our QML application. And I'll leave that up just as a means to go and find out more if you wanted to. And then at this point, invite questions.
Thank you, Phil, for sharing your workflow with us for performance analyzing. Questions?
Could you just give a few words about the tool? What's the price? It is free, and so on.
Sure. So the instrumentation, so that is the trace points within our Linux-based solution, and that's all LGPL. So those trace points are available. They haven't been pushed back to the project yet. It's still early days in our Qt work, but that is the ongoing discussion. The software tool itself is available under our own development suite, and at this point, the means. It's a case of understanding uptake and use and discussions about pushing it back then into the community for wider use, if that is perceived as the next step. So the trace data, the trace points are available, so that will give you access to this to the Qt-based seeding of tracing that we've done, but then the tool for the means of analysis is within Mentor Embedded's development tools, but the negotiations regarding pushing that out to the community are underway.
How is the instrumentation done specifically? Is it
So this is it is JavaScript within the Eclipse environment within the tool. So within those, so these ones that you are provided with, whether that's the kernel analysis, CPU analysis, this is just a JavaScript within the Eclipse environment to present you with the idea of configurable options, but they are tied into the trace points underneath. I haven't got that low down with it yet, but the customizable analysis agents is you don't have to, if you use the tool, you don't have to be an expert and build yourself an agent that appears in this list. You'll be able to access all of your trace points through this custom wizard for building analysis agents, and choose the different types of graph that you can make.
No, I mean there must be some instrumentation in my own program, or not?
No, just so yeah, you would need to add your trace points. You need to. So if we have a look here, you can see examples of. So it's an API call to the trace tool technology. So under Linux, it's using LTTNG as the tracing technology that's underneath, and under Nucleus, it's our own tracing software.
So, for example, if I want to see memory consumption, then I can only see this consumption at the trace point that I have made.
No, because memory consumption would be done for you, just as a if you wanted to see, I guess your dynamic memory allocation, you mean within your application, where if you're allocating memory within there, you would get that memory allocation would appear within your graphs for up and down. But if you wanted to see like specifics around that function where you are allocating the memory, then yes, you would add your own trace points.
Okay.
Okay, so I think that's it. Thank you for attending the talk, and thanks again, Phil.
Thank you.